Hello, everybody.
Hello, everybody.
Hi, Klaus.
Hello, Robert.
Yeah, this is Fun with RELUX. And today we have an interesting episode about
the maintenance factor.
The maintenance factor.
Everybody has heard about it, but who knows it?
Everybody's using it, but maybe wrong. So maintenance factor is one of the key factors you should be aware of if you are doing lighting design. Yeah, it's really quite important. That's why we have we set up this episode to inform you all about what is interesting and what you need to know about the maintenance factor and how you can operate this maintenance factor in RELUX Desktop. And we have a presentation to guide you through the basics, through the standards which are involved, and yeah, just to tell what is it and what should you be aware of. And after the presentation, we going into RELUX Desktop and show you directly in the software what you can set there and what you should set there in terms of maintenance. Yeah. In general,
in general, the maintenance factor is in the planning. We lost light in our light scene, in our lighting installation during the lifetime of this. And so for that reason, we need to install more light into our lighting installation than really is required. And then from one point, so we start to clean up the rooms, clean the luminaires, replace the lamps, and so on. We go back to a higher value, and that point is called the maintenance value, the maintenance level.
Yeah. So bad news. Your installation, your planning will be lost in efficiency. It will lost in brightness, lost in illumination values, lumens, and so on. So whatever you plan, it will lose in performance over the time. And and this is something you have to deal with factors. This is something which happens, which is natural, that we have a degradation in light, but we need to calculate it. We need to deal with it, and we need to plan this. And that's why we have this maintenance factor and this whole maintenance surrounding. And you as a lighting designer need to deal with it in order to calculate the right values for your right dimensionation of your installation. So let's jump into the presentation. So I switch on the presentation here again. So now you should see exactly the same screen as before, but I just move one slide more. And sorry for the German, I did not found the English reference. Licht.de has also a lot of English written graphs, but this one is I just found in German. But don't care, it's not about the text on it, it's about the graph we can see. Here it's about maintenance cycles. So what we have said was that we have here after the installation. So this point here is the first point after the installation. So we call it in German something like new value, new plan value.
The initial value.
The initial value of your installation in illumination, and then after the usage it drops down. So your performance, the illumination levels will be going down to N level, and this level which is reached shortly before a maintenance cycle, this we call in German Wartungswert, in English is something like a requirement or in maintenance value. Exactly, the maintenance value. And the maintenance value, the maintained value, is the value which is in the standard. So in 12464, for example, on the desks is 500 lux. This is this maintained value. So the value which happens shortly after the next maintenance cycles. This means if we have here a 500 lux line, this means we have here something like 620 something lux in order to have after a degradation of the light output that we have still by minimum 500 lux. So it's okay to have more, and but in the end we need by minimum even shortly after maintenance, then we need to have these values after the 12464. That's why it's called maintained illumination value in the standard. And but also this means we need more light. We need to dimension to plan more light as we need in order to deal with maintenance. And the distance here between our maintained value and our fresh installed value, this is the maintenance factor in a way. So this is the buffer we create in order to having always the minimum required illumination levels. And after maintenance, maintenance could be mostly cleaning luminaires, exchange lamps, renovate, repaint the room, whatever is required to gain back the new state. Most of it, it's about the lamp, to re-enable the lamp to put out the lumens again. So by replacing the lamp in old times, in new times with LEDs, exchange LED modules, or even exchange complete lumina after a certain time. So also this cycles is also depending on what you have installed in which situation. And if you do not do any maintenance, you're just dropping down and dropping down at some certain point to zero. Even with LEDs, it will be decrease to zero after, depend on the usage, how long it will be. So, and the whole maintenance story is just about dealing with the loss of illumination after years. Okay, so the next slide show you the formula. There's one formula which allows us to calculate the stuff. And here we have the maintenance factor, and this equals the lamp lumen maintenance factor. So this is about lumen output. So the lumen output will drop after a certain time. So this is the degradation of the output in lumens of the lamp or lumina in the end. Depends on if you have an LED lumina. And also by the second factor, this is the survival factor, the lamp survival factor. And this is a factor for just the operation of the complete lamp. So a lamp could be in the past broke, that you have a complete complete Boolean 1 or 0 lost of the complete lamp, especially on the old high pressured or a negative pressured environment. Then a bulb could be broken, and then you have the survival factor of the lamp. And this both is about the lamp or the light source. In nowadays, it's a bit hard to distinguish between lumina and lamp. This we will see later. So these two factors, lumen loss and lamp survival, is down to the lamp. Then we have a factor called lumina maintenance factor. This is about the housing, the lumina itself. So the diffuser, for example, or the reflector, this will get more dirty after a certain time. This will be lost in the functionalities of the diffuser. The material will get more worse after a certain time. So this will be drop, and also lenses, for example, but even also ballasts can be also getting worse and worse over time. And this is the factor is reflecting this loss of functionality of the lumina, especially of the optics and the photometrical parts of it. And the fourth and last factor we have in the maintenance factor, this is about the room or surface maintenance factor. So this is down to especially in indoor situations where the room has also a big impact to the illumination. So the reflections from the wall, especially if you have white walls and a bright area, this has a really big impact to the illumination values. And this impact will also getting lost according time, because the walls getting more dirt and have less reflection, and with less reflection you have less light on the surface on your task area, and then it's also a factor for maintenance. And you can also maintain the surfaces of the room by just repainting the stuff and bring the original state back to it. So these four factors determines the maintenance factor. yeah, from an impact, I have to say the room has less impact. Also, the lumina itself has a bit of an impact, depending on the lumina structure a lot. So if the lumina is direct or indirect, or has a diffuser or is open, this has a high impact. And the highest impact is the lamp and the lumen loss. The lumen loss maintenance factor. This has the highest impact in general on the maintenance factor itself. But we will see in detail. So this formula, which we have seen, is out of the CIE 97. This standard, the CIE 97, yeah, is all about maintenance. And in this standard, you have this formula, but also explanations and descriptions, what is maintenance and how to calculate. And not even the basics, you have also a lot of tables in the standards. And in these tables, you can see in the tables you have values for certain azimuths. So for example, here's a table, sorry, it's German again. I do not have on the English version. Here, for example, we have the room maintenance factor, the room and surface maintenance factors, down to specific reflection decrease of the rooms. And here, of course, if you have a white, bright room, the degradation has a higher impact on this as a more darker room. Yeah.
It's more sensible for when the walls become dirty.
Mm-hmm.
So if you have real dark walls, then the impact is not so high as if you have clean white walls when they start getting dirty.
Yeah, and you found some diagrams like this, but also those diagrams, tables where you can really do math and put the values out of the tables in your calculation and calculate the maintenance factor. Here also another example. This is the lumina maintenance factor, and here we have a specific type of lumina. This is type C. There are up to type F in the luminas, if I remember correctly, or G, and then you have different surroundings. So, for example, if you have a clean surrounding or a very clean surrounding, then you have less an impact of the lumina maintenance factor, and if you have a dirty environment, then it has a bigger impact on the lumina maintenance factor after certain time. What is important to know on the CIE 97 is that it's quite old. So it's from the current version is from 2005. This comes from an era where LEDs were not really in place. This was the starting point of LEDs, so the first prototypes of LED luminars, no, even before. So it's really low. It's really the era before LED, and so and this is also an point where it's hard to deal with. There was also close to a decade where nobody was really knowing what is about maintenance factor in LED. So somebody was some guys were assuming, okay, LEDs never going out. There's the survival factor always 1, and the lumen loss is quite low on LEDs. They last forever, so we put just 1 into it. This is wrong. There's also a degradation of the output of an LED light, and that has a lot to do with quality and with lifetime and so on. And for this, there is a new standard, a relatively new standard from 2019, also 5 years ago. But this is an ISO CIE technical specification, so in standard, the 22012. And this is dealing with maintenance, especially for LEDs. So this is referencing to the CIE 97, so it's still valid, and CIE 97 is still in use for lumina types, for the room and so on. But in the 22012, you have values also for LEDs. You have the lumina, the lamp lumen output maintenance factor in tables like this in the standards, and in these tables, this is you can calculate the loss of lumen outputs by the useful life or the lifetime, which is the LED lumina create for. You have probably seen some values like an L, LB in hour value. So, for example, if you have an L80 50,000 hours LED lumina, you found this on data sheets of the luminas. So L80 50,000 hours lumina has after 40,000 hours of usage. So this is the usage time. So we just use 40,000 hours of our 50,000 lasting lumina, and we get a lumen loss maintenance factor of 0.84. And surprise, if you're using your L80 50,000 hours lumina 50,000 hours, you end up with this 80. That's why the L80, this is the 80. This is just 80% of the original after 50,000 hours. This is the definition of this L value. There's also a B value. It's just mentioned here. For all this, we have this median useful lifetime, and median means B50. B50 is something the whole industry, at least in Europe, has in consensus that everybody should deal and publicated just B50 values, because this is the median, the middle of these values of this loss of an spread of different luminas. And yeah, that's why it's 50. So if you have a B10 this description on the data sheet, there should always be also NB50, or it's also possible to recalculate, but then you should know the lumina.
I guess it's also interesting. I'm not sure if you can read this note in the bottom here at the end. There is also described that according to this standard and this way to formula, the B value is not taken into account for the maintenance factor determination.
Yeah, this makes it also more complicated.
Makes it a little bit easier in the handling, in the practical usage of this.
Yeah, and this has a benefit for the designers, for the users of this. If everybody is dealing just with B50, then you have something you can really compare. It's hard to compare in B10 and the B50 because it's just a different range of values. Okay, so this is these are the table, and this standard is also important for the LED era in order to have this maintenance values for the lumen loss factors. There's also a table for survival and so on. It's also in the standard.
Yes, we are proud that we have included in the RELUX already.
Yeah, and we will show you soon. So this is a maintenance plan. Maintenance plan is something every lighting designer should deal with in a way. This is also set as a standard procedure in 12464 to deal with maintenance, to have a maintenance plan, or at least to communicate it. This is an example which we create in Windows Desktop. So in Windows Desktop, you can get a maintenance plan. You should not, do not need to create it by hand. You get one out of Windows Desktop as an output. If you go through this through the schedule, so you need to set the maintenance factor according to the CIE 7097 and also to the ISO CIE 22012. After this, you get a maintenance plan. If you do not do this maintenance settings, you get not a maintenance plan, then you have just a fixed value, which is by default 0.8. At least here in Germany, we're using a lot of 0.8, but this is just down to I always say a cultural impact. This 0.8, which is commonly used in Germany as a maintenance factor, there's no reference to it. There's no standard, there's no documentation. It's just 0.8, and this means you can try to set with CIE 97 something with an interval in cycles, an environment where you end up with 0.8, but this is not something which is in the standard. So there's no standard telling you you have to use 0.8. This is really up to you, to your maintenance, to your luminas, to your situation, to your environment, and of course, according to maintenance. It should be so the ideal situation would be that you get from your architect, from your potentially future facility manager, or from the owner, or from some building manager and maintenance plan. You can ask as a lighting designer for a maintenance plan where you found information like how often the luminas are cleaned, how often the room is renovated, repainted, how often are happening lamp exchanges, lumina exchanges, whatever. This information you can use in order to fill it up, and then you get a maintenance plan and a maintenance factor. out of it. But in reality, it's quite seldom, at least here in Germany, that you get a maintenance plan out of from your architect. So you have just nothing, or maybe some estimations, and it's flipped around, that the lighting designer has to deal with a maintenance plan, that you have to do a lot of estimations. So you have to guess that it will be cleaned after 4 years, that every lamp is replaced, that the room is used this much hours per year. So you do a lot of estimations, and with these estimations you gain or you get a maintenance factor, and this needs to be communicated. So it always needs to be communicated that you have used your own maintenance factor, even if you're using 0.8 as a reference, as a quasi standard, which has no reference. But if you're using 0.8, you need to communicate to your client, to the user of your lighting design, that you has taken 0.8 because you do not have anything else from him. You really need to be serious, because this 0.8 has a deep impact to the complete calculation, to the amount of luminance, to the illumination levels, to the energy consumption. Everybody is linear connected to the maintenance factor. So if you have a maintenance factor of 1 in relation to 0.5, you need the double the lumina. You need to have more light power in order to deal with this maintenance gap. So this is really serious, that you communicate at least, and maybe by providing the results and with communicating, I did not get any maintenance information from you. I need to do estimations. I need to guess something, and this is my guess. Maybe you get send something back as, oh, we maintain quite often, and if you have a serious maintenance in the building, you can have less luminance in it. This is really the case. So if you have a good maintenance, if you clean the environment, then you need less energy, less luminance, and has a better design. And if this is unclear, or if you want to be on the sure side and providing a big maintenance gap and calculate with 0.5 or something, then you need really more of energy, of luminance, in order to deal with this maintenance gap. This is really serious, and at least you need to communicate it. If the client is fine, then he is fine, but he needs to adapt the real situation to your design, and your design does not fit if the maintenance does not fit, at least in this really important factor. Okay, enough of theory. Let's go into RELUX Desktop and check it out, how it looks. So I prepared already a standard room with a standard calculation with 2 types of luminance. And here in calculation, you can find the calculation manager, and and on the top of the calculation manager, you found here the maintenance factor. You can set it directly in the ribbon, the 0.80 or whatever in the maintenance factor. But in the calculation manager, you found here the maintenance factor, and here you have the classical 0.8. And here we have also added in a button to add in reason. Reason means you can here text whatever you mean why you have chosen 0.8. It could be, I do not get any maintenance information from you. I just choose 0.8 because I assume you have a clean environment and proper maintenance, because 0.8 is more and best guess of maintenance situation. So it's more a positive projection of the future, the 0.8, more conservative. So for example, the colleagues in Austria really likes more to calculate a maintenance factor of 0.67. This is also a cultural thing down in Austria, and also for the reason, because we did not know, we picked something which should be usual in maintenance. And here you can type in freely why you choose this value. And this comes also in the output. And if you go the serious way, if you really deal with maintenance, you can click here for each lumina type and to determine. And here you get, if you want to, you can also click it away. You get also information from us which standards we are using in order to calculate this value. And here we have the CIE 97, of course. We have also here the LED ISO CIE 22012 from 2019, but we have also added 2 more publications. One is from the German ZVOE. There was a publication for the decredidation of lumen outputs of this harsh lamp. So also quite old, and also from Philips catalog for I guess for tubes and for the good old fluorescent lamps for their decredidation as an example. Of course, manufacturers can also provide you with degradation curves that you know, okay, after these years I have this left in lumen outputs. And this, of course, is the better way. But here we have some examples. And it looks like this. So you have here interior, exterior. There's a slight, but not a too big difference in outdoor maintenance factor with the same components, of course. But the room is just surface. It's not has not the big environment. Has not the biggest
dirty or clean environment.
Yeah. And yeah, here you can go for the lumina type. So this maintenance happens per lumina type because the lumina types act differently in maintenance. So for example, lifetime can be different. So we have to do it for each lumina type at least. And here you can set, here above you can set the environment. So if you have a clean environment or very clean or normal, this is down to CRE 97. So for example, we have here very clean. And what is the maintenance interval? So you maintain every 2 years, for example. And you can see here directly the maintenance factor for this lumina is changing by setting directly. So if you go here for just 5 years in maintenance, we get a not so good maintenance factor in contrast to just every 2 years. So this is changing, also if it's clean or not clean. And here we have the lumina type. So this is the reflection decrease comes also out of the room. You can click here determine and you get the reflection decrease out of your scene directly in it. And also the characteristic is comes from the lumina. So if you switch here to indirect, it switches here automatically of the characteristic. It's just direct, indirect. And the indirect lumina has more potentially to get the dirt on the top side. That's why it's getting less good values, more worse values in the lumina maintenance factor. Also, if it's closed or open, yeah, it's up to G. If it's an uplight, yeah, this is down to the lumina type and how often you make maintenance on the luminas. So here above, it's maintenance on the room, on the environment, and here it's maintenance on the lumina. So every year, for example. And here, most interesting with the biggest impact is the lamp factor. So this both values here are reflected to what you set here. So here we have room, and here this factor is about the lumina, and here this both is about the lamp. And here for lamp, of course, we need to tell if it's a good old fluorescent lamp, compact, induction, high pressure sodium, whatever. Of course, most of the time, I'm sure you're getting down to LED. And in LED, you have to set if it's an L70, L80, or L90 in lifetime. And this lifetime, we have just this values for lifetime because the table in the CRE ISO document is just limited to these values. Of course, it's possible to have another values, but you need to recalculate the lifetime to this common values. We not extrapolate this table to something else. So L80 is some kind of standard, 80 or more. I guess 70 is really seldom. This is value, but you can also recalculate different lifetimes to different Ls. It's just a point on the curve of degradation. Yeah, and here we have to enter the lifetime. So for example, our popular 50,000 hours, and if you have an L80, 50,000 hours, and the operation time, this is the time you actually use this lumina. The lifetime is how long the lumina could last after the data sheet of the manufacturer, and operation time is the time you use this lumina before maintenance. And surprise, we have here an 80 and a lifespan of 1, so it's not cannot broke potentially. And we have also an 80 direct for the lamp's luminous flux factor. And if we going down, and if we say, okay, I have an office environment, I just need the lumina 8 hours a day for 3 years, so it's just 22,000 hours. Then you gain in the lamp's luminous factor with 0.90 instead of 0.8. It's just because we do not need so much of this lumina, so we need less operation time from this long lifetime, and we gain more luminous flux by the point of maintenance. So this is a really important setting. So if you can tell the luminaire is just used 8 hours per day for 3 years, then you can calculate this and enter this here. And of course, also in luminaire with a higher quality. So if you have an LED luminaire which do not just last 50,000 hours, if you have a luminaire which lasts 80,000 hours and you still just use 25,000 hours of this luminaire, you gain even more maintenance factor. So here you are now on 0.94 instead of 0.8 if you use your 50,000 hours luminaire 50,000 hours. So this is something quite interesting for lighting design, because again, this factor goes directly linear in the result of luminous flux, in power consumption, in amount of luminaires, in everything, just linear. And it's a big difference of 0.94 for luminous flux factor instead of 0.8. So this has an impact. And if you use your 50,000 hours luminaire more than 50,000 hours, so for example 60,000 hours, then you also see a drop in the survival factor. Of course, then you play with the risk that the luminaire is not lasting over time a lot, and also the luminous flux factors going down just straighter as in the normal usage time. Yeah, and here below you have all these values straight multiplied to the maintenance factor. I forgot to mention there's also a constant light output. This is also popular in a couple of street lights. If you click through this luminaire and you need also to be inside the lifetime, you just gain 1. Because constant light output means you have just the same light output, the same luminous flux over the complete operation time, by dimming after time just upwards. So the loss of lumen outputs is compensated by a dimming. So it starts in a dim situation and it dims down to up to 100% over the lifetime slowly, that you just have the constant light output. This is technically possible, and you find it also in the market with CLO or constant light output, and with this tick you can tell RELUX, okay, I have a constant light output. Constant light output luminaires often just have a ramp over a certain hour time and just dimming up, but there's also some technology which takes in the temperature of the luminaires and also the actual usage time and so on. There are quite different options on the market. And if you have a brightness sensor in your situation, so if you work with a daylight detection sensor, which also control the illumination level on the desk, for example. So if you have it also connected, the light sensor with the interior situation, then you have also some kind of light, the constant light output, because the luminaire is always leveled to the requirements of the situation. Then you have also a constant light output. But of course, the ramp is not going into the lumen output, but the ramp is going into energy consumption. So you gain after a certain time more energy consumption as on the start time. So nothing comes from nothing. So you gain a constant output with a raise of energy consumption. Okay, and of course you can also here make notes of it. You can also write here something in which comes to the output, where you can tell, okay, I have done these estimations. I have calculated the operation time like this. You can type it here in. And if you have some manual input, you can also put in here your own values for this 4 factors in, and make your own calculations with the real standards in your hand, or with a real luminous flux degradation curve from your manufacturer, and can tell after a certain time of maintenance, okay, this is the spot I have an own luminous factor from a diagram from a data sheet. Yeah.
And this will also be documented in the print outputs of the RELUX.
Yeah. Okay, good. Then if you click OK, then you end up after the calculation with the maintenance plan. You can find it here, somewhere here. Yeah, here's the maintenance plan, looking like this, with all the stuff we set it for the luminaires is here documented, just printed out. and then you are done with this, and you can gain more than 0.8. But of course, if you be realistic, in some situations you're also getting less than 0.8. I have to say, in most situations I have less than 0.8. But with the LED and so on, you have options. Yeah, and this also you can also flip it around and tell how much the luminaire can be used in order to get this factor in this result. So this is a formula which can be easy flipped over to another point.
Important is that you have it in your documentation, in your communication with your clients, and
yeah. Okay, good. There's also a general setting that you can switch it forever. So I just show it quickly. There's in general setting, default values, calculation, and here is a tick, maintenance factor separate for each luminaire type. If you switch this on, then you get always, in all standard situations by default, this own maintenance plan behave of RELUX Desktop.
Yes. Also, in this dialog, you can change the default from 0.8 to a lower or a higher value.
Yeah.
If you prefer this as a general maintenance factor. And also, you will find here some points which is related. RELUX is a really old program, so you have also the possibility to use a planning factor. So this is used really long time ago. You don't work with maintenance factors. You work with planning factor. That means you're starting. If you have a requirement for example, 500 lux, then you start with 25% more than 500 lux as an initial value.
Yeah.
And also in the past we have this loss factor, reduction factor instead of maintenance factor.
It's not really in use anymore, so maintenance factor it is today. And yeah, good. Okay, then this was the presentation. Let's go down to the questions. So I switched off the screen sharing and I put the questions. If we have some questions to our screen, yeah, there are a couple of questions. Just try to extend it here. Okay, first question. Could you please explain briefly most important factors and calculation maintenance factors for external lighting? For example, car parks, railway stations, platforms, publics, walkways, and so on. Klaus, what do you use for maintenance factors outdoor?
In outdoor, you have seen there is also the option to run this tool for outdoor calculation, and outdoor is also a little bit related to that what you are saying. In outdoor, it's related because the typically we have not this problematic about the luminaire maintenance factor because we have typically just direct lighting, and so the dirt on the light is not so critical as it is in indoor, because indoor indirect light and the dust stuffs from the top on it has great impact. Also in the indoor lighting, we have the reflection from the walls, which is also not happens on the things. And also we have in the exterior situations a lot of this constant light with the LEDs.
Yeah.
Then here is RELUX calculating the emergency calculation by removing all indirect light and only using the direct traction applied to the emergency maintenance factor. These are two different points. In the emergency lighting, it's a little bit a kind of discussion about what to calculate for emergency lighting, and for safety reasons, it is recommended only to calculate just the direct light on the measuring surface, because here we have the problem, how can you really guarantee that the walls are really in this reflection degree as you tend to the planning. And so that is the one thing. We have an option actually that allows to also calculate the first indoor reflection from the indirect light, but this is
just for UK.
But this is not. It is not recommended to use this in normally situations. Also, we have typically in emergency light situations, especially the emergency lighting for escape routes or something like that. are normally luminaires for just direct light.
Mm-hmm.
And you should be able to have at least this one lux in the center of your escape route only with the direct light from this emergency lightings. According to the maintenance factor of the luminaires, there is a little bit of thing. Typically in these situations, these luminaires are only used in the emergency situation. Mm-hmm. So we have not the loss factor from this luminaires. It's a little bit related to what kind of installation you have. For that, you have the possibility to use the maintenance factor, a separate maintenance factor for the emergency lighting, but it's a little bit a special point in all these things.
Yeah, you need to think about if you have an emergency luminaire which is just taken into account in an emergency situation, then you can raise the maintenance factor to close to 1. Because you have not the room factor anymore, because you have just taken them part direct light. Just there's a technical memorandum on in UK which allows you to have 1 intersection, but I would not go for it, even not in the UK. Just take the direct part. So you have not the room factor anymore. You still have the luminaire factor and the light loss and so on, and survival factor. Survival factor maybe can also tear out of the equation. But if you have a luminaire which is just used for emergency light, you can go close to 1 for the maintenance factor. But if you have a luminaire which also makes a normal illumination and just on the side in terms of emergency gets DC voltage and then drops down to a certain level, then you have to deal with the full maintenance factor of the luminaire and of the lamp, because this is in use and have also in degradation, or to be on the sure side, of course. Good. Next question. If the maintenance factor of operation is set at 0.85, shall the emergency maintenance factor also set to the same or with a little less? Again, so if the same luminaire does emergency and the normal situation, you have to deal with the same maintenance factor. So 0.85, not less for maintenance, because it's the same luminaire. If you have a separate luminaire, you can go even higher to 1, depending on what do you think, what the luminaire is down to aging without being operated. There's also an aging in LEDs if they are not switched on, and this you need to deal with. Not so easy. Doing the emergency calculation, so maybe the last question to emergency. During the emergency calculation, how the required calculation area are determined? How to determine the escape routes and the panic area in general if no information is provided. You need to have, this is down to emergency, you need to know where are the areas for emergency escape route and the panic areas. You need to know it. You cannot just tell, oh, there's a desk, there's a hallway, there should be an escape route. You need to know, really. You cannot do it by your own. Do not do as a lighting designer an escape route planning. Do not do it, even if you get paid for it. Do not do it. Something really special. If you have the skills, if you have done this training, if you know the local requirements, if you know everything, then please go ahead. But not just, okay, I need to place luminaires for it, so I do the design of the escape route. This is really not. You should not do it. It's for legal issues, for everything. No, do not do it. They are professionals, and you need to deal with so much more than just lighting. If you go down to escape routes, door with building regulations. There's a lot of stuff. You need to know this from somebody who doing it professional for this situation on this site. Is there any online calculation tool to work out precisely the number of operation hours for luminaires, which we know when the luminaire will be switched off, for example, between 11 p.m. and 5 a.m., depending on the location of the luminaire, north-south, close equation? No, I don't know any. No, I cannot say. I cannot tell that there is nothing out there. There potentially are some tools which help you, but I just don't know one for operation hours. I just used my Excel stuff
Yes. Also, at the moment, you must see a little bit all this kind of maintenance calculation, maintenance factor calculation is an estimation. It is not a high, precise calculation. You should seriously take care that you have as much luminaire power installed in your situation that also after this maintenance circle you have enough light on it. So it is close to impossible to have it exactly at the end. So you have so many situations and you have so many situations which you cannot control during this planning process. It is more an estimation than really. So it is not important to have really every working hour attached to this calculation.
So there are a couple of more questions. I just go for one question and then we have to close the session. Is there an isn't rule of thumb maintenance factor set to 0.8? Yeah. No, not really. So of course everybody is using 0.8, and if everybody is doing 0.8, at least you can compare the designs. So it's possible if everybody is concluding to 0.8 that you can compare the designs between them. But 0.8 is more on the optimistic side of maintenance. So 0.8 is something which is for reality situations a bit too high, a bit too optimistic. And there's no reference. Of course, you need to calculate backwards the CRE 79, and then you will see, okay, I can get in 0.8 by a clean, very clean arrangement within 2 years of maintenance cycles with really good direct luminars. In these situations, you have this 0.8, but it's not reality. And it's maybe
it's an historical, traditional value. That's the reason why we have it still inside of the program. It is related to the situation, as Robert tells. So in some situation, it may be okay. In other situation, it will be not okay.
You need to communicate. You need to communicate, and it's also possible if you have a design which has another calculation factor, you can also easily linear shift the other value. So it's also possible if you have done all the calculations and so I forgot to calculate the maintenance factor, or I need to reset the maintenance factor. You can calculate the light output or the amount of luminars also linear with another loop maintenance factor. So it's completely linear in it. Yeah.
From the handling and calculation side, it is much more comfortable if you have just one maintenance factor, which is linear inside of the calculation, also for some serial things.
Okay, we have to close. Our next episode number 35, it's happening on the 27th of June. So 27th of June, also on Thursday, also the same time slot. And we will discuss and talk about UGR. Glaring, just UGR. We had one episode for glaring in general, but this episode will be just down to the UGR calculation. Will also be quite interesting and also a bit more theoretic. Yeah, thanks, Lars. Thanks together.
And hope to see you next time, and bye. Have a good day.
See you. Bye.